So up to this point, what we've done is we've learned a little bit about the derivative. And so remember the idea of this f prime of x is that I say derivative, and hopefully you think rate of change. And so the derivative gives us the rate of change of the function. Right, this means that the second derivative, if you think about it, it's simply the rate of change of the function, or we can just say it's the rate of change of the derivative. We talked about a couple of ways of finding these. The main way we took a look at this was using the definition. And so the definition of the derivative, the limit, is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And the last couple of days we've been using this definition to try to approximate the derivative, and then also find the derivative if I give you a formula or even a graph. Now today we want to talk about how the derivative measures change. So this is an important topic. The idea though is relatively simple. So let me remind you, first of all, how functions can change. Right, so let's go back and remind ourselves that a function can change in a number of ways. It can either increase or decrease. So that means it can go up or it can go down. When a function increases and decreases, we often get a local maximum. So if you go up and you go down, you get a local maximum, whereas if you go down and go up, you get a local minimum. So here you have a local max. I'm just going to label it max. And then here you have a local min. This also illustrates the concave up and concave down activity. So when the function's frowning, it's concave down. Whereas when it's smiling, the function is concave up. All right, so what the derivative actually tells us about a function, it turns out that the first derivative, and let me highlight it up here, the first derivative actually tells us when a function's increasing or decreasing, whereas the second derivative will tell us about the concavity, whether the function is concave up and concave down. And it depends upon the sign of the function. So here, let me write down the rule. Right, so what do derivatives tell us? Well, the first derivative tells us whether a function's increasing or decreasing. So the idea is this: if f prime of x is bigger than 0, if it's positive, then f of x is increasing. So I'm just going to write up. Whereas if f prime of x is negative, so it's less than 0, right, then f of x is decreasing there. So that's for the first derivative. Now the second derivative gives us concavity. So if f double prime of x is greater than 0, then f of x is concave up. So Cu. And then if f double prime of x is less than 0, so it's negative, then f of x is concave down. And these actually go both ways. So what that means, this means that if f of x is increasing, then we know the derivative is positive. So it goes the other way too. Right, so let me illustrate that by just simply drawing an arrow. So if this is true, then we know that is true. If this is true, we know that is true. If this is true, we know that is true. If this is true, we know that is true. So it goes both ways. The way you can remember this, it's very simple to remember. You just remember this little saying, positive ideas go with positive quantities, and negative ideas go with negative quantities. As I'm running out of room here, so up here I even dropped off the IT, but whatever. So it's just a little saying, and it's very simple. All right, so positive ideas. So if the first derivative is positive, let's highlight this. So if the first derivative is positive, either goes with the idea of going up or going down, and positive idea is going up. Whereas if the derivative is negative, if the first derivative is negative, so the first derivative is negative, then it goes with the negative idea of concave down. And then if the second derivative is positive, that's a positive quantity, it goes with the positive idea of concave up. It's a smile, smiling to positive. Whereas if the second derivative is negative, it goes with the negative idea of concave down. So why is this true? All right, so once we understand or memorize this rule, we typically would like to ask ourselves a question: why, if the first derivative is positive, I know the function is increasing? And that one's actually pretty easy for me to explain to you guys. And so it comes from this fact that if I say derivative, you say what? And you say this means rate of change. So it all comes from this idea that the derivative is actually the rate of change of the function. So if the first derivative is positive, right, so if this this derivative here, and circle it here, if this derivative is positive, right, that means the rate of change is positive. So of course the function's going up. If the rate of change is positive, it can only go up. And when I say rate of change, it's like I'm making, let's say, $200 per year. Since it's positive, I'm making more. Now, if it was negative, if I was losing $200 a year, then certainly it would go down. So this first part, conceptually, really, it's very easy to explain to you. Why, if that first derivative is positive, it's going to go, the function's going to go up, whereas if the first derivative is negative, the function is going to go down. The second part's a little bit harder. So let's think about this second part. Now, the reason it's harder is because it involves the second derivative. And the second derivative is not only once removed from the function, in some sense, it is twice removed from the function. So this one here is a little bit harder to get to. But you can kind of see it, and here's how I see it. If you look down here at concave down, what can you say about what's going on here? If you look at the tangent lines, you can see here at concave down, here's one tangent line, and it has a positive rate of change. And then the next tangent line, let's say right here, has no rate of change, so 0. And then if you look over here, what do you see? Well, you see a negative rate of change because it's going down. So what's happening to the rate of changes? Well, the rate of change the changes are going from positive to 0 to negative. So the rate of changes are decreasing. So the rate of change is decreasing, so it's going down. And remember, I say rate of change, you say, what do you say? If I can find this little dot. So you say derivative. So this means not just the rate of change, but actually the derivative is decreasing. So what does it mean for the derivative to decrease? That means its derivative, the second derivative, must be less than 0, because the second derivative is the rate of change of the first derivative. Now look over here. We can look at a tangent line here. That's a bad tangent line, but you see it's going down, so it has a negative rate of change, a negative derivative. Here the derivative is 0. And over here, the rate of change, or we can say the derivative, is positive because it's going up. And so now I notice that the rate of change is going from negative to 0 to positive. So the rate of change is increasing, or we could write the derivative is increasing. So it's going up, which means its derivative, f double prime of x, or just write f double prime, must be bigger than 0. I think it's worthwhile to think about what I just said here and try to understand why, when the second derivative is positive or negative, it tells us about concavity. Okay, let's take a look at our first example using these ideas. And so example 1 is about Google's stock price again. So it says, let Google's stock price, and I'm going to pause this, try to get rid of this, so hold on one sec. Okay, I think I fixed that. So here it says that Google stock price S in dollars be given as a function of t years after 2005, and each part below determine the signs. So we're going to determine the signs of S prime and S double prime. All right. So in part A, it says a broker commented that Google's stock price was increasing at an increasing rate. So let's draw this. So the idea is maybe we can make a graph. And here we would put time. And here we'd put Google's stock price. So let's just put stock price. And it says it's increasing at an increasing rate. So the idea is, maybe I start down here and I go up here. And now there are basically 3 ways I can do this. I can do it by going concave up. I can do it with a straight line. So imagine that this is a straight line. And then I could also do it by going concave down. So in part A, and actually I think I'm going to use this picture for part A and part B. So let me get rid of this right here and write A underneath it. Find my little pen here. So part A. So which color, red, blue, or green, indicates that the stock price is increasing at an increasing rate? So if you look at these, you can kind of see that this one, the red one, this is increasing, but the rates are going from some positive number to a less positive number. So here it has a decreasing rate. Whereas in the blue, it's supposed to be the line, so if you pick any point on there, you always get the same rate of change. Right? So here the derivative is constant, whereas here the derivative is actually getting smaller, it's decreasing. Whereas down here, the derivative starts out positive, and then up here it becomes even more positive because it's steeper. So here the rates of change are increasing. So the answer for this one would be the green. And so I know that on this one, I know that S prime, since it's increasing, it's bigger than 0. And S double prime, again, look at the green. S double prime is concave up, so positive idea goes with positive quantity, so S double prime must also be bigger than 0. Now let's look at part B. Part B says the broker commented that Google's stock price was increasing at a decreasing rate. And so instead of the green, this is going to be the red. This, for a similar reason, if you look at this, I have a positive slope here, and this one's less positive. Right? So the rates are decreasing, the derivative is decreasing. And what I know is that S prime is still bigger than 0 because the function's going up. Right? Because it's going up, I know S prime is bigger than 0. But because it's concave down, this implies that S double prime is less than 0. Just like up here, the green was concave up, so I implied S double prime was bigger than 0. Right? Concave down is a frown, so that's a negative idea, so it goes with the negative quantity. All right, finally in part C, now this is where you have to be a bit careful. So in part C it says the broker commented that Google stock price was decreasing at an increasing rate. So on this one, let's draw the picture of the possible cases. So here's my time. Here's my stock price. And now instead of starting down here, I'm going to start up here and go down because it says it's decreasing. And again, I can draw my 3 cases. So I could go down in a concave up manner. And actually, I'm going to try to make that a little bit more concave up, I think. So I can come down in a concave up manner. I can go down at a constant rate of change. So that's just a line. So imagine that this blue thing is a straight line. And then I could also be, instead of concave up, I could come down in a concave down manner. That looks good. And so now I want to figure out, okay, these are all decreasing, so, I know since it's decreasing, that's a negative idea, so S prime would be less than 0, so the first derivative is less than 0 because the function is decreasing. Google's stock price is going down. But for double prime, I have to determine, which color curve it is. Is it green, blue, and red? Now I know it's not blue because blue has a constant rate of change. And it says the rate is increasing. And so what you need to do is think about these numbers here. So now this is going down, and this is going down steeper. So if I was going to assign a number here, this is going to be negative. So this might be like, let's say, -1. Where this is steeper, so it's like -10. And then the green here, this is really steep, and then down here it's less steep. And so this is like -10 to -1. Now these are rates of change. So let's, you can put actual money on here. This could be like -$1 per year. And this is going down $, -$10 per year. Whereas this 10, you're first losing $-10 per year, but now you're just losing over here at -1. This is -1. You're losing $-1 per year. Now, which one is an increasing rate? And this is where you have to be careful. So if you think about this, I'm losing here $-10 a year, and now I'm losing $-1, a year here, and now I'm losing $-10 a year. So the rate is going from a number which is -1 is actually bigger, right, than -10. So this is actually a decreasing rate. Whereas this one down here, I'm going from $-10 a year to $-1 a year. So I'm losing a lot here, but I'm not losing so much here. So this number, negative 10, is less than negative 1. So here the rate of change is actually increasing. So it turns out that the answer to part C is actually the green graph, because the rates are increasing. I'm going from negative $10 to a larger number, negative $1, because negative 10 again is less than negative 1. So this is concave up since it's a green graph, and now I know S double prime is bigger than 0. Remember, positive idea of concave up goes with the positive quantity, so S double prime is bigger than 0. Very easy to remember. Positive ideas go with positive quantities, negative ideas go with negative quantities. The next example we want to do is we want to fill out this table. So let's take a look at this table here, and it says fill in the table with positive, negative, or 0. And so the idea, let's make this a little bigger. The idea is to use this graph right here and try to figure out when the function first is positive or negative. So this is the function part. So figure out first when the function part is positive or negative, then figure out when the derivative is positive or negative, and then figure out when the second derivative is positive or negative. And this all comes from trying to remember if the function is increasing, the first derivative is positive. If the function is decreasing, the first derivative is negative. Right? Positive idea, positive quantity, negative idea, negative quantity. Whereas if the second derivative is positive, it's concave up, or the second derivative is negative, it's concave down. So positive quantity goes with positive idea, negative quantity goes with negative idea. Also, the complexity of the ideas go together. If you think about it, you first learned increasing and decreasing, so it goes with the first derivative, the first thing you learned. And then you learned about concavity, that's the second thing, and it feels a little more complicated, so it goes with the slightly more complicated idea of second derivative. All right, so let's go through this. And so what I want to do first is I want to look at this this number, this input of negative 2. And so for negative 2, I come over here, and so input of negative 2, and I come down right here. I'm on the graph, and I realize the height is certainly negative, so I put a minus sign. And the function, you can see here, it's going down, so it has a negative derivative, a negative rate of change, so it's negative. Whereas it's part of a smile right here, so this is part of a smile, so it must be concave up. So if it's concave up, it's positive. Positive ideas go with positive quantities, negative ideas go with negative quantities. Let's look at the next point. So now we want to look at negative 1. And so negative 1 is right here. And it's supposed to correspond to this point right at the bottom. And I realize the height is negative. Right, the rate of change now, the rate of change, it looks like it's supposed to have no rate of change, so it's 0. It's neither increasing nor decreasing. And it's certainly part of a smile here. And so it's concave up, so it's also positive. Right, so second derivative must be positive because it's concave up. And then finally, if we look over here at 2, so here's 2, the input 2, so I go up on the graph, I look right here. I see that it's going down, so it has a negative rate of change. Oops, and I skipped the first one. It has positive height, obviously. Positive height, and then it has a negative rate of change because it's going down, and then it's part of this smile right here, and so it must be concave. Oh, not a smile, but a frown, so it must be concave down, and so that's negative. Now, an interesting point to look at here, to make note of, might be this point right about here. And we're going to call this the inflection point. It's where the concavity changes. All right, so that black point is called the inflection point. Of course, the input is 0. And at 0, it has a negative height. The function is going up. You can see that. It's going up here. So it's increasing. So the first derivative would be positive. Whereas now the second derivative, since it's neither concave up nor concave down. Can you guess what it would be? Positive, negative, or should be 0. Because remember, if it was positive, that would mean it's concave up. If it was negative, it would mean it's concave down. But it's an inflection point. If you think back, we define an inflection point to be a point where there's no concavity. It's where we change from concave up to concave down. Okay, so this completes this lecture on how derivatives measure change. And so hopefully, if I ask you the question, what do derivatives tell us? They tell us how a function changes. So if I know the sign of the first derivative, I can tell you where the function's increasing and decreasing. And if I know the sign of the second derivative, I can tell you where the function's concave up and concave down.